The mean value theorem is one of the most simple yet useful theorems in calculus. You know that in math, the word mean is another way of saying the average. Likewise, the mean value theorem is all about proving that the instantaneous rate of change exists from the average rate of change. Great, how do we do that? Imagine Dino is taking a trip in his car. At hour 0, he traveled 0 miles, but 2 hours later, he's traveled a total of 120 miles as seen on the graph. From this, we can find his average rate of change. Calculating the rise over the run, we know that his average rate of change was 60 miles per hour over that interval. Even though we don't know Dino's exact speed at every moment between hour 0 and hour 2, we know that at some point during his trip, Dino's speed must have been exactly 60 miles per hour because that was his average rate of change. And that's exactly how he got his ticket. That is the main idea behind the mean value theorem. Take a look at this function, f of x. F of x is a differentiable function, meaning that for each point on the function, the derivative exists. Since the function is differentiable, we can also infer that f of x must be a continuous function, no holes, jumps, or gaps. Think of it like Dino on the highway. At each point in time, he had a speed and covered a specific distance. Alright, so the function is differentiable. Now let's put these 2 points on the function, point A and point B. What is the average rate of change on this closed interval from A to B? That means we include the endpoints. Well, the average rate of change would just be the slope of the line that passes through both points, or the change in y over the change in x. This is all stuff you already know. As you also know, on different points on the open interval A to B, not including the endpoints, the instantaneous rate of change may be greater than or less than the average rate of change. But because the function is continuous, that means somewhere on the function, the instantaneous rate of change has to equal the average rate of change. That's the whole point of the mean value theorem. The mean value theorem tells us that if a function is differentiable between point A and point B, then between point A and B, there must be at least one x value where the instantaneous rate of change equals the average rate of change. The instantaneous rate of change is also the derivative. This makes the mean value theorem extremely useful in proving that certain derivatives exist. For example, in this differentiable function, g of x, we know that g of 1 equals 3 and g of 4 equals 0. Can we prove that at some x value between 1 and 4, the derivative must equal negative 1? According to the mean value theorem, since the function is differentiable, we know that if the average rate of change over that interval is negative 1, some derivative in the interval will be equal to negative 1. So what is the average rate of change? The change in y over the interval from 1 to 4 is 3 minus 0, and the change in x is 1 minus 4. So the average rate of change is 3 over negative 3, or negative 1. That means, according to the mean value theorem, we know that at least somewhere on this graph, there has to be at least one derivative that equals negative 1. No matter how we draw g of x, at least one point has an instantaneous rate of change of negative 1. Now, what would happen if a function was not differentiable? Check out this function, j of x. J is a continuous function, but it's not differentiable at 1. Since the average rate of change over the interval from 0 to 3 is 0, can we prove using the mean value theorem that somewhere between 0 and 3, there must be a derivative that equals 0? Well, no. Here, the mean value theorem would not apply. As you can see on the graph, because the derivative does not exist at 1, there doesn't have to be a point where the instantaneous rate of change equals the average rate of change. Now, of course, there might be, but it's not guaranteed. So, to use the mean value theorem, the interval of interest must be differentiable. To sum up the mean value theorem, if we know a function is differentiable between point A and point B, and the endpoints also exist, then we can prove that there has to be at least one point between that interval where the derivative equals the average rate of change of that interval. That's the mean value theorem. If you found something helpful in this video, consider giving it a like, subscribe to the channel, and tell your friends how math can get you a speeding ticket. Now, keep working hard and keep learning. Thank you for watching.